These notes go on page 73 in your notebooks. Our content objective is we will be able to identify and apply direct variation when given a graph, equation, or y varies directly as x statement. And your heading should be direct variation. In a direct variation, the relationship between x and y is proportional. And that's what we were doing on Friday. We were using those rods to represent proportional relationships. The relationship can be written as y divided by x equals k, or as y equals kx. K is known as the constant of variation. And all direct variation equations are written like this, with y equals kx. But you can determine k just by using y divided by x. The graphs of direct variation equations all have this one trait in common. So looking at this graph, we know all direct variation equations have y and x intercepts of 0. So that means that all direct variations pass through the point 0, 0. Direct variation can also be determined by using a set of ordered pairs or a table. If y divided by x is the same value for all of the pairs, then the set is a direct variation. So as an example, we're going to take 4, 3. We have to find out what that equals. Well, 3 divided by 4 equals 0.75. And then 6 divided by 8 equals 0.75. And 9 divided by 12 equals 0.75. So what I did there is I divided y by x for each one of my ordered pairs. And we found out that every single one of them was equal to 0.75. So since that was the case, they were, and they are, a direct variation. And we can do the same thing with the table. So we can take our y value, so 1 divided by 2 equals 0.5. 2 divided by 4 equals 0.5. And 3 divided by 6 equals 0.5. So since all of those are the same, once again we see that this is a direct variation. So seeing what you've seen in these notes so far, I would like for you to determine if the following are direct variations. So you're going to look at the representation, so either the graph, ordered pairs, or equation. Tell me yes or no, and then also tell me why yes or why no. Let's try something a little bit more difficult. So this problem says the value of y varies directly with x. That's the key statement that we have in all of these. The value of y varies directly with x. Write a function that represents the relationship between x and y. So a function means we know we're going to have y equals. So that's where we're going to start. But then what we need to do is we need to figure out what y divided by x equals. So we know y is 4 and x is 10. And that can be simplified to 2 over 5. Because if we divide the top by 2, the bottom by 2, we get 2 over 5. So that means we're going to take this value and we're going to write it right here. We're going to say 2 over 5x. That is the equation. So really these are pretty simple. All you need to do is know that you're supposed to take your y value, divide it by your x value, and then plug it into the equation. This will work for direct variation equations. This one, same concept, except now it's just a little bit more difficult. The value of y varies directly with x, so same thing. Write a function that represents the relationship between x and y if y equals 10/3 when x equals 20. So we know we're going to have y equals. We also know that we need to take y divided by x and figure out what that is. Well, if y is 10/3, and we're going to divide that by 20, what that really means is that we are going to end up with 10 over 3 times 20, which is 10 over 60. So when that gets simplified, it's 1 over 6. And that is my equation. Easy stuff. Okay, that's it for today. We're going to have a quiz on Tuesday, November 12th.